Thousands of kilometers south of the launch site, rocket scientist David Knudsen, a former student of Kindner's, makes his way into the University of Calgary.
I find it amazing that when we go up to the edge of space, which is 100 kilometers above us, we're just getting out of the atmosphere. The first thing we encounter is the lower boundary of the aurora. And right away, we're presented with a puzzle that we can't solve.
Knudsen is on his way to a meeting with colleagues where they'll discuss the remaining questions surrounding the aurora.
It's still a big mystery. I don't really understand how it can happen, why it happens, and exactly how. And I don't know if anybody can answer that.
You can study the aurora.
Knudsen's colleague, Eric Donovan, explains the basics of what we do know about the aurora and hints at what we don't know.
Environment. If you want to understand the aurora, you have to understand the interaction of the solar wind with the Earth's magnetic field and how that extracts energy from the solar wind, and then you have to understand mechanically how an electron hitting a molecule in the atmosphere causes it, excites it and causes it to give off light. And we understand pretty much the mechanical goings-on the ionospheric end, and we understand pretty much the extraction of energy from the solar wind. But then in between that, you have, how the electrons individually get their energy and are fired at the Earth's at the upper atmosphere, and how structure arises in the aurora.
Once the source of structure is understood, I bet that's the key to the acceleration, and maybe vice versa. If you guys can figure this out, there's a Nobel Prize.
For these auroral scientists and others around the world, the first big mystery is discovering how the particles coming from the sun are accelerated so quickly into the upper atmosphere to form the aurora. What is firing them downward? The second big question is, what causes the complex, beautiful curls, vortices, and filaments inside the aurora? These shapes are present at the largest and smallest scales, from kilometers wide to meters across. Answering these questions will unlock the secrets of the aurora and, at the same time, help us understand the workings of the cosmos.
They told us it was all clear in Churchill, province to the north.
Compared to last night, it's clearing up already. Like right now, this is not actually cold out there. It's just we get a lot of ground drifting.
David Knudsen is fighting his way through an Arctic blizzard to a research station where, weather permitting, he will try to study the aurora. Knudsen needs the weather to clear, since he makes only one trip a year to this remote location. He's come to meet his University of Calgary team, not to launch rockets, but instead to observe the aurora.
For those of us who spend most of our time building space instruments, it's important to actually get out and look at the aurora from time to time instead of spending all of our time looking at squiggly lines on a computer screen.
For decades, Churchill was the mecca for auroral scientists who came here to launch hundreds of experimental rockets into the Northern Lights. Now abandoned, the rocket range is left to the local Inuit people, a few scientific researchers, and polar bears. Northern peoples, like the Inuit, had explanations for the aurora long before the arrival of rocket scientists. For the Inuit, the aurora is the bridge to the other world, lit by torches held by dead ancestors, guiding lights for the recently deceased. Across the Arctic, the ancient Vikings saw the lights as dead warrior maidens or Valkyries. For all of these ancient cultures, the aurora was potentially dangerous and could harm the viewer if provoked. Medieval Europeans believed that the aurora was a harbinger of apocalyptic doom. Within the last 250 years, scientists and polar explorers began to keep detailed records of the aurora and classified what they were observing. Visual observations, though, couldn't properly explain the causes of the aurora. Throughout the 19th century, scientists around the world began to notice a link between the occurrence of sunspots and the aurora, hinting that the sun might be responsible for this beautiful phenomenon. At the turn of the 20th century, Norwegian scientist Christian Birkeland had the idea that particles from the sun hitting the Earth's outer atmosphere created the aurora. He felt he had proved his hypothesis in a dramatic lab experiment in which he fired electrons at a magnetic model of the Earth, generating an artificial aurora. The idea that space is not empty, but filled with energized particles was revolutionary, and the world's scientific community refused to believe him. He eventually died of a drug overdose in Japan. It wasn't until the late 1950s that some of the first auroral rockets launched from Churchill helped validate Birkeland's theory. The rockets confirmed the existence of the electron beams that cause the visible aurora. And 50 years after those launches, auroral scientists are looking to answer the remaining questions about the Northern Lights. Knudsen and his team are hoping to conduct an experiment to answer a question that has fascinated people for centuries. Can you hear the aurora here on Earth?
So this is the search coil right here. It's sensitive up to several hundred hertz. But we're going to hear up into the audio range with this any electromagnetic waves that are associated with flickering aurora. Auroral sound is a phenomenon that has not been recorded scientifically yet, whereas there are many, many eyewitnesses or ear witnesses to auroral sound, and they describe that when the aurora is intense and dynamic, they hear a swooshing or a hissing sound.
Physically, it's impossible for sound waves generated by the aurora to travel down to Earth and still be audible. But radio waves generated by the aurora, which we can't hear, do reach us. This is what they sound like when recorded with a radio antenna. Knudsen thinks that something in the environment, rocks or trees, might act like a radio and turn these signals into audible sound so that we can hear them unassisted.
There have been experiments where people are blindfolded and they can actually point out or they can predict the times when the aurora is brightest.